Within our authentication form, we're going to be dealing with many pieces of state that depict how the UI is going to be composed for the user. This allows us to control how the composables look and behave. To model this, we're going to start here by creating a new class called Authentication State. We're going to want to make this a data class so that we can access some of the utilities provided by this. This allows us to easily compare our classes. This also gives us access to the copy function that makes it easy for us to update the individual properties of our state. We'll start here with the content that is going to be input by the user. This is the email address and the password. Because this is something that the user will enter and be displayed within our UI, each of these is going to represent a piece of state in our model. For this, we're going to go ahead and add 2 string references to our state class. These are going to be nullable with default values of null, as when the screen is initialized, these won't have any content. Alongside the user being able to enter their password, we're going to enforce some requirements for that password. We'll represent these in the form of an enum. This allows us to enforce the length and content of the password that is required. We'll define 3 requirements here: a capital letter, a number, along with the password need to be 8 characters. For each of these requirements, we're going to want to show a message when they aren't satisfied. This will be used to communicate what the requirement is to the user. For this, we'll need to start by adding some new strings to our strings resources file. We'll add 1 for each of the requirements we've defined, which gives a clear message for each of the requirements. We'll then need to adjust the password requirement to contain a label in the form of a string resource integer. We can then set a resource for each of the required enums that we previously defined. With these now defined, we'll now need to update our state object. Within the state, we'll need the current password requirements that are satisfied so that we communicate this to the user. For this reason, we're going to add a new password requirements field to our state that represents a list of requirements that have been met based on the password input. Because a user is able to sign up or sign into our application, we need to allow the user to toggle between these 2 states. To be able to represent this state, we're going to start by defining a new enum that will be used to signify whether the form is currently being used to sign up or sign in. This will be a new enum called Authentication Mode with both the sign up and sign in value. We can now go ahead and add this to our state. This will then allow us to easily toggle between these 2 modes and have our UI recompose whenever the selected mode changes. We give this a default value of sign in, allowing the user to switch to sign up should they require. Now that our state represents both a sign in and sign up flow, we're going to want to be able to handle the state when the user reaches the point of performing these operations. While we won't be hitting an API in our UI, in the real world this will be an asynchronous operation, meaning that we would have to wait a second or 2 for it to complete. In this scenario, we would want to show a progress indicator to the user so that they know a request is taking place. We'll represent this in our state by adding a loading flag to the state class in the form of a boolean. We're going to give a default value for false for this, because when the screen is initialized, it won't be loading as there is nothing to load from the network request. Once the loading request has completed, we want to handle a response that will come back from our API. In the case of a success, we will be navigating to the next part of our application, but things might not always go as planned. And in these cases, we want to show an error to the user, usually in the form of the error that has come back from the API. To allow for this, we'll add a new field to our state class, which will represent if an error has occurred and at the same time, the content of the error. As well as the content that can be entered into the input fields, the user can also delete this content. These fields themselves will start blank, so in both of these cases, we don't want the user to be able to submit the form. We also want to block the form from being submitted if the password requirements have not been met. To handle these cases and these different kinds of logic, we're going to add a new function to our state class. This will return a Boolean value that represents whether the form content is valid. We're using a function for this so that the place that has access to this state can easily check if the current state allows the user to proceed, instead of adding another value within our state. Here, we simply want to check that the password is not empty, the email is not empty. If the authentication mode is either sign in or the password requirements have been met, then the user can log in. We don't need to check the password requirements on sign in because the user would have already created an account. With this in place, we now have a class that can be used to represent the state of our UI. Over the next sections of this chapter, we'll utilize this state when building our UI, modifying its values as any interactions with composables take place, triggering recompositions to reflect any state changes.